Hello everyone, I am here with a new problem which is named frog jump on Leetcode. So this is today's Leetcode problem of the day, and this is marked hard, but I think it is not a hard question. If you consider recursion and dynamic programming, it is a basic problem of dynamic programming. Okay, now first let's go through the problem statement. A frog is crossing a river. The river is divided into some number of units, and at each unit there may or may not exist a stone. The frog can jump on any stone. The frog can jump on a stone, but it must not jump into water. Note that point. It must not jump into water. Given a list of stone positions in sorted ascending order. So we are given a vector stones with positions in where stones are placed in sorted ascending order. I will tell about that why sorted ascending order. Okay. Determine if the frog can cross the river by landing on the last stone. So we have to determine that the frog can land on last stone or not. Initially the frog is on the first stone. So here it is given that initially the frog is on the first stone, and we have to assume that the first jump must be of 1 unit. So if frog is on 0th index, if frog is on 0th index initially, it can jump 0 plus 1. That means it can jump 1 unit, and it can place itself on a position on 1. And if there is a stone in 1st position, we can say that frog is safe. Okay. Now, if frog last jump was k units, its next jump must be either k minus 1. So if previously frog jumps k unit, now it is on a stone after this jump. Okay. Now it has three possibilities. It can jump k minus, basically it can jump k minus 1 unit. Okay, k minus 1 unit. It can jump the same unit, that is k, and it can jump k plus 1 unit. So it has three choices. Okay, so it has three choices, k plus 1. Got it? And the frog can only jump in forward direction. That means the frog will have to go in this direction only. It cannot jump backward direction. That has been given in the question. Okay, so we have to determine that the frog can, it is possible for the frog landing on the last stone or not. If it is possible, we have to return true. If it is not possible, we have to return false. Okay, now come on the example. I will explain this question with an example. See this. So these are the position of stones, and initially frog is on 0. Now it is given in the question that from the initial stage it can jump only 1 unit. Okay, so 0 plus 1, it is on now 1, and 1 is present. That means on 1st position we have a stone. That means frog is safe. Okay, so then go forward. Now on 1th index, we have three choices. That means if previously k is 1, that means the previous jump unit was 1. Now it can jump k minus 1, that means 1 minus 1, which is 0 unit. Okay, 1 k same 1 unit, and 1 plus 1, that means k plus 1, that is 2 unit. Got it? That is 2 unit. Now if frog jumps 0 unit, does it hold any significance? No. See, if frog is on 0 and it will take a jump of 0 unit, again frog is on that index. Again it will take a 0, it will take a jump of 0 unit. So does it take any significance? Because frog is on the same index. Frog is on the same index again and again. It is not possible for the frog to move forward or for go in the last index. Okay, now so we will discard this, that if a jump is of 0 unit, we will discard it because it is not possible for a frog with a 0 unit jump to place on the last index. Okay, so now it will take a jump of 1 unit. So 1 plus 1, 2. So frog is on tooth position. Okay, but on tooth position, does we have any kind of stone? No. See that stone's position. Do you see here 2? No. 2 is not present. So frog is not safe. So we will return false. That if you come on tooth position, I cannot go forward because I am now on water. So return false. Okay. Now it can jump 2 unit. So frog is on now 2 plus 1, which is on third position. So third position is safe. Yes, third position is safe because on third position we have a stone. So frog is safe. Now from the third position where frog can go. So previously we have a jump of 2 units. So now we can jump 2 minus 1, which is 1 unit, 2 unit, and 2 plus 1, which is 3 unit. So first explore this 1 unit. Okay, if jump is on 1 unit, so 3 plus 1, frog is on fourth position. So is there any kind of stone on fourth position? No. See that position. So we don't have any kind of stone. So frog is not safe. Okay. So I will return false. That frog is not safe. I cannot go forward after fourth position because I am now on water. If I jump after 3, if I jump 1 unit, I am in the water. So 1 unit jump is not possible. If I jump 2 unit, if I jump 2 unit, so 3 plus 2, 5. Does 5 is safe? Yes, 5 is safe because we have one stone on fifth position. Okay, so go forward. Now, from 5, what are the choices? So, previously we have a jump of 2 unit. Now we can jump 2 minus 1, which is 1 unit, 2 unit, and 2 plus 1, 3 unit. Because we have chances k minus 1, k, and k plus 1. Okay, now explore this first. So 5 plus 1, I am on now 6th position. I am on now 6th position. So from 6th position, it is possible to jump. Is it possible to jump from 6th position? Does we have any kind of stone on 6th position? Yes, we have a stone on 6th position. So is it safe? Yes, it is safe. So go through it. Now on the 6th position, what are the jumps possible? So previously I have a jump 1. Now 1 minus 1 minus 1. That means 0. So if our jump is 0, that that doesn't hold any kind of significance. So we return false from there. This part is clear. Why 0 doesn't hold any kind of significance? I think it is clear because if you are on 6, if you have a jump of 0 unit, you will again on this stone. So it is not possible to go on the last stone with 0 jump. So directly we will return false, that it is not possible to jump with 0 unit. Okay. Now what are the chances? Rest. What are the chances I have? Now 1. So 6 plus 1, I am on now 7th stone. Does any kind of stone present in 7th stone? No. From the vector, I am seeing that there is no stone on 7th position. Okay. So I will directly return false because from the 6th position, if I take a jump of 1 unit, I am now on the water. So it is good to not take that jump. Okay. So return false. Now 1 plus 1, 2. I can take a 2 unit jump. 2 plus 6, which is I am now on the 8th position. So there is any stone or not? From the vector or from the storage, I can say yes. In 8th position, I have a stone. So go through it. Okay. Now, previously I have taken a jump of 2. Now I have to check. Now, what are my choices? 2 minus 1, which is 1, 2, and 2 plus 1, which is 3. Now, if I take a jump of 1 unit, 8 plus 1, 9. 9 is not present. 9 is not present. 9 is not present. So, we directly return false. 8 plus 2, 10. 10 is not present. So, directly return false. 8 plus 3, 11. 11 is not present. No stone is present on that indexes. That's why we have to return that false. If we take one jump, 1 unit jump, 2 unit jump, and 3 unit jump from 8 stone, it is not possible to go on last index because I am now on water. So it is preferable not take the jump. Okay. So false, false, false. So I will return false. That from 8 index, I don't have any choice of jump by which I can go on last index. So from 8 index, it is not possible. So return false, false, false. So I can assure that from the 6th index, if I am on 6th stone, it is not possible to go in the last position because in which part I have gone, it will give me false that I am on the water. So from the 6th position, it is not possible to go on the last position. So return false. Now explore this part. If I have a jump of 2, so 5 plus 2 is 7. Does we have any kind of stone on 7? No, we don't have any kind of stone. So I am now on water. If I take the jump of 2 from the 5th index, I am on the water now. So better to not take this. So return false. Now I am on 3 because 2 I can take the jump of 3 units. So 5 plus 3 is 8. So I am on now 8th position. So is it possible to stay on 8th stone? Yes, there is a stone in 8. So it is safe. Now previously I have taken a jump of 3 units. Now I have 3 choices. 3 minus 1 is 2, 3 itself, and 3 plus 1, 4. Okay. Now first go through that 2 unit jump. So 8 plus 2 is 10. But 10 is not present in the array. That means we have no stone in 10th position. So better to not take this. So return false. Return false. And 8 plus 3 is 11. 11 is also not present in the array. That means we have no stone in our 11th position. So return false because if you take if because from 8, if you take 3 unit jump, you are on 11 and you are in water. So better to not take this jump. Now you can take 4 unit jump. 8 plus 4 is 12. Okay. Now see, on 12th I have a stone. So I am safe now. So I can take that jump. So jump this. Okay. Now I am on 12. Previously I have taken a jump of 4 unit. So what are my choices now? 4 minus 1 is 3, 4 itself, and 4 plus 1 is 5. So first explore this 3 unit jump. 12 plus 3 is 15. Okay, but on 15 we don't have any kind of stone there. So return false. You can see that 15 we don't have any kind of stone. So return. 12 plus 4, which is 12 plus 4, which is 16, which is 16. Okay, but on 16th position, we don't have any kind of stone. So better to not take that jump. So return false. 12 plus 5, 17. Now we can say that we have a value 17 in our last position. So I am on the last index. So return true because there is a path from 12, which is I can jump 5 units from 12 and I am on the 17th, and which is my last stone. So I am able to present myself in there. So return true. Now this path will give you false, this path will give you false, but you have one path which will give you true. So eventually you can follow that path and you are on 17, which is the last index. So eventually it is possible. That's why I will return true, because false, false, true. There is one path we can follow, we can go to 17. That's why I am returning true, that it is possible. I have one path by which I can go on to the last index. That's why it is true. Okay. Now, if it is true, it will return you true unless and until. Okay, it will return you true. Now, it is true, it will return you true. So, it will return you true. Okay, so you don't care about this node, because in three choices, if one choice will give you true, you can follow that path and you can present yourself in the last index. That's why if it is follow, if it is false, and if it is true, we don't care about this index or this path, because I have one path. If I follow this path, I can present myself, or the frog can present itself onto the last index. Okay, so it is returning true, and eventually it will return true, and it will return true. Okay, it will return true, and 0 will return true. So our answer will be true. Got that point? So it is a simple recursion problem. We have three choices. We have to explore all of that. Now come on the time complexity part. So we have three choices on each index. So I can say that time complexity will be at around big O of 3 to the power n. Big O of 3 to the power n. Okay, but stones dot length is 2000. So it will give me a TLE if I follow that approach. So I have to optimize it. So how to optimize this? Obviously, to optimize recursion, we use a DP. First, understand the recursion approach. So I have created another set integer s in which I have saved my stones, that in which position I have stones, because if you carefully see, you can see that on each index first I have to check if it is safe to place on that position, or I have to go back. So I can have a set, okay, by which I can assure that is it safe or not, and I have a target in globally. I have a target so that I can avoid the passing parameter. So I have a target stones n minus 1. Whenever I made my target, I will return true. Okay, so target is stones of n minus 1. N is the size of the stone. Okay, and n minus 1 obviously the last index. Now I am returning this. So they said that I can take one jump. I can take one jump. So our recursion will start from there or there. Our recursion will start from here. Okay, our recursion will start from 1 obviously. So just omit this. Just check this portion by yourself. How can we check? Using that line first. That using that line first. That means if stones of 0 plus 1 not equal to stones of 1, that means if zeroth position, that means if 0 plus 1 is not 1. Okay, something said I have 0 in zeroth position and 2 on first position. So is it possible? So it is not valid because 0 plus 1 is 1 and we have no stone in one position. Okay, so that's why we can eliminate or we can check this part by yourself. Okay, so stones of 0 plus 1, stones of 0 plus 1, that means 0 plus 1 in this example is equal to 1. So 0 plus 1 will be 1. Okay, 0 plus 1 will be 1. Okay, so 1. Now 0 plus 1 will be 1. If it is not equal to stone of 1, that then we are unable to go forward and uh, forgot to place yourself on last index. So I will directly return false. And my recursion state will start from here. My recursion start from here. So previously I have a jump of 1 unit, so I have to keep track of it, that I have a jump of 1 and I am on the stone. Which stone? Stones of 0 plus 1. Stones of 0 plus 1. You can write stones of 1 also. You can write stones of 1 also. Okay. Now I have to, obviously we have to keep track of previous jump and we have to keep track of position. Now if position is equal to target, that means if position is equal to last index value, then we will return what? We will return true. Then we will return true. And see, if previous jump is equal to 0, that means 0 has, if previous jump 0, so 0 has no significance, as you can see in this node 6, 0 jump, return false, because if you are on 6, you take 0 unit jump, you are on the same index. That doesn't hold any kind of significance. So return false. And I have one condition, s dot find, which means I have to check if the position is safe or not. That means we have a stone on that position or not. S dot find is equal to s dot end. That means we have no stone on that position. We have no stone on that position because previously you can see that I stored the stones. I stored the indexes, or I stored the position of the stones in S, so that I can use that thing S dot find. So that I can use that thing S dot find of position. Okay, if position is not found, that means we have no stones in that position. So return false. Got that point? Okay. Now we have three choices. Choice 1, choice 2, choice 3. That means k minus 1, k and k plus 1. So first choice 1. So we can have a jump, previous jump minus 1. So we have a previous jump. So now if we have a previously we jumped 2 unit. Now we can jump 2 minus 1 unit. That the thing. Previously you have previous jump. Now you can jump previous jump minus 1. And you are on the position plus previous jump minus 1. So you are on the position 3. Previously you jumped 2. So 2 minus 1, 1. And you are on the position plus 1. 3 plus 1. You are on 4. So previous position plus previous jump minus 1. You are on that index. Choice 2. What is my choice? See, what is my choice? So jump on previous unit. So what is my choice? Jump on previous, like jump previous unit, previous jump unit. So I have jumped previous unit and I am now on the position plus previous jump. See that? You are on the 5 and previously you have jumped 2 units, so again you can jump 2 units, so you are on 5 plus 2 7, that thing. And you have choice 3, that means previous jump plus 1 unit. So previous jump plus 1, and your position is now position plus previous jump plus 1. Okay, suppose that thing, previously you have jumped for 2 unit, now you are on 5, so you can jump 2 plus 1 3 unit, and you are on 5 plus 3 8 position. Got that point? Now return ch1 or ch2 or ch3, whichever will give you true, you will return true, and if three of all will give you false, you will return false, because in that case, if I have one path which will give me true, I can assure that if I will go through that path, I am able to present myself on last index. Okay, so if one path will return you true, return true. Okay, that path. If amongst these three paths, one path will return you true, return true, but it will give you clearly. So we have to optimize this. So I have created a map pair int bool mp. You can name it bp. I have named it mp. Okay. So map pair of int comma int, because we have two parameters which are changing. One is previous jump and one is position. So I have one previous jump and I have position. So that two are changing. So I have to take care of that thing, pair of int comma int, and I have to store the result inside that map. So store that result which is bool, so that whichever I have one state which is already calculated, again whenever I face that problem, I don't have to go deeper down, because I already solved that problem. From map I can return its result. Okay, that the intuition behind it, that the intuition of dynamic programming. Okay, that if you previously solve a problem, again you face that problem in another branch, don't go deep down, don't go deep down, you have calculated the answer previously, so just return that answer from your stored thing, for your dynamic, for your data structure. Okay, now here mp.insert, before returning I am saving the answer, which is mp.insert previous jump comma position comma ch of 1 or ch of 2 or ch of 3, which will give me true. I stored 2, and if amongst 3 everyone will give me false, I will store false. On which parameters? Previous jump and position, because these two are changing. You can see these two are changing. Previous jump minus 1, position plus, these two are changing. That's why you have to take care of these two parameters. Okay, and the same thing I have told, that if you previously solved that problem, and again you face that problem or that thing, don't go deep down, just return the stored answer. And here is the thing. So here is the thing. You can create a iterator which will create you which will return you that previous jump comma position, mp.find previous jump comma position, and you have the key with yourself. Now auto it, you have the key with yourself. So previous jump comma position, you have the iterator, and if iterator not equal to mp.end, and if iterator not equal to mp.end, so you have that iterator inside your map. That means previously you have solved that problem, that's why you have to that's why you stored it inside your map in that step. Okay, in that step. So just if it not equal to mp.n, that means previously you have solved it, so just return the stored answer, which is it of second, which will return you this thing, this boolean thing, which will return you this boolean thing. Okay, so just return. By that method, you can able to optimize this in n square. Why n square? because previously you are checking everything. For every choice you go deep down, but in here, if you solve one portion, you don't have to go for this again. If you solve this, if there is a overlapping sub problem, you don't have to go deeper down. Okay, that's why you have to visit only previous jump into position. That's why you have to go previous jump into position. So previous jump into position stage. So our MP, or you can say DP, our MP will visit only previous jump into position number of states. So a previous jump and position, we can say roughly n square. Okay. So our time complexity will be n square, order of n square, and our space complexity same. You are you want previous jump, like there are how many number of keys there are in map, how many number of keys you will store. The number of keys will be previous jump into position, so the space complexity will be order of n square. The space complexity will be order of n square. Okay, because I have previous jump into position number of keys inside my map. Okay, so the space complexity is clear or not? I think it will be clear. Okay, so how I left something, uh, I have tell about this point, that why I have to write this thing. Okay, and target. Okay, so no, I have cleared everything. So your time complexity will be order of n square and space complexity will be order of n square after memoizing. Thanks for watching.